Okay. See here, I got my link back up. Fred, kw5gp. There is not a link besides ARRL. However, on the w5obm.us/Arduino site, where we keep the code for the book, you can see a detailed listing of all of the book code and the projects there. W0IH, I got my link back up. All you got to do is type in the chat room and I'll catch your question. Before we went to the break, somebody asked a question, and I'm sorry I missed it. Please repeat any questions that I haven't answered. I'm trying to remember what the question was. It scrolled by and I saw it and needed to answer it. But anyway, we're going to be changing up some of the equipment. Okay, here we go. There's really not a better debug interface. I'll slow down, KD5XX. There's really not a better debug than that. I try to just get functions within the project to work, and that's part of my debug. Throw it up on the LCD display, something of that nature, blink an LED or change a color if I'm in a certain block of the code. And N5IKD, I'm sorry, no, the book is not available as an ebook. And the website, I'll say it real slow. Grab your pens, write this down. Let's go old school. Remember I told you need that pencil and chart at the start of the show? It's w5obm.us. Whiskey 5 Oscar Bravo Mike.us. And you can do a /Arduino to take you directly to the Arduino POS page. And that's the question, kw5gp Rob. Yes, it is possible to link to the internet and control the rotor with a smartphone through the internet. And as a matter of fact, this was going to be a topic of discussion a little later on. Let me pop over to it. Oh, that's right, I lost my mouse. All right, well, we'll handle these questions. Can we get RF out of the Arduino for a beacon? Absolutely yes. There's this really cool thing called a DDS, Direct Digital Synthesis chip, and I'm going to show you that in a little bit. The DDS chip, they want my mic gain up a little bit. Can we get my mic? Yeah, my mic gain. The DDS chip will allow you to directly synthesize a frequency from 0, and depending on the module, all the way up to 75, 90 megahertz, thereabouts. So you can crank it up and turn yourself into a little VFO. It is accurate to the within, I'm never going to say that word again. It is accurate to within 0.1 hertz. Stable, crystal derived, digitally controlled. And we're going to talk about this a little bit later on. Let's see. We were talking about the link to the Ethernet. And, Mike, this is the EasyVR voice recognition module. And this will plug directly onto the Arduino. It's got the shield pins, got a microphone. This will recognize 28 voice-independent commands, and you can program in another, I think it's 30, don't hold me to that, 30, 32, but you can program in another bunch of custom voice commands into this. Now, let's put this across the room with the rotor controller. Now you just tell your rotor where you want it to turn. You don't even need a mouse or get up or move. So that's kind of where I'm going with my rotor controllers. I want to be able to sit in the back of the room and tell them where to turn. And no, my glasses did not come from Prince Mongo. Mike, you're horrible. But, and yes, VE3DV. With the CDE rotor, I did have major issues. In fact, with the scratch-built version, there are two versions that I have built. I built one totally from scratch. The noise was so bad that I almost threw the project out, because the way the CDE rotors work, they have the 26 volts AC that's powering the motor drive is sharing the same ground as the 5 volts or 6 volts that they're using to sense the position on that little resistor in the top of the bell. I did not want anybody to have to climb their tower and modify that bell to split the ground. So what we did on that module, we actually snuck around, and again, this is just one of those, if you talk around to enough folks and you're listening, something's going to come together. Because I was talking to somebody about the CDE rotor, and they were like, well, you know, when I turn mine, it always stops, and then I have to let it settle, and then I move it to exactly where I'm doing, because it's never accurate. Well, that gave me the clue. I actually fell back to old school, and we actually did a time versus rotational speed calculation in the Arduino. So while it's moving and I've got that high noise unreadable condition, I'm actually calculating where I think it is. And then when I get to the end point, I stop, and as soon as the voltage stops, the motor voltage goes away, the readings are just 16-bit dead accurate. So you get your position, and it works no better, no worse than the existing one. On the modified one, which you just saw, it was a lot easier. The A to D that I use is a 16-bit with a 6-level selection by software. So I have gain control. I actually tap directly across the meter on this CDE controller and read the ultra low voltage. The book will tell you the voltage amount. I can't remember off the top of my head. It's like 50 millivolts or 120, 100, very low millivolt range. But because of the gain, I'm able to get enough resolution that I can see what the meter is seeing. And because the meter has that nice little core of coiled wire, which turns into a choke, it filters out a lot of the AC. It's all filtered. There's a little bit of noise, but what I'm doing, I'm actually reading differentially across the meter, so I'm not seeing any noise. So that's a backdoor way of filtering out the noise. I ignore the noise while I'm moving, then when I stop, I read, and I'm reading dead across the meter. So that's how we did the modified one and got around the noise problems. And in the book, somebody's talking about the DDS VFO. In the book, I actually was building an audio generator, and the final answer I came up with was the DDS module. And so there's actually a DDS module. Dual antenna connected to the ARD. What is that exactly? I don't know. That's in the intro. Tom is going to have to tell you that one. And yes, they do have power over Ethernet modules for these shields. The voice recognition board is called the Easy VR Shield 2.0. Easy Victor Romeo Shield. And I am not giving this one away. You can, no, not happening. No. Mine. The advantage over an easy rotor controller, you built it. You program it. It's whatever you want it to be. I chose the Yaesu simply because I like the command code set. It was easy to work with, and it adapted everywhere else. So, you can easily do with that Easy VR. You could do the voice announce amateur radio repeater controller, and you can add a whole bunch of things. I think we were talking on the Facebook page the other day about a weather station on a repeater with the speech board. Oh, okay. He's off doing other things. I think that question is probably more for Tom if he's going to be at the Orlando Hamfest. Tom's kind of busy at the moment right now. So we'll get that one back to you. Anybody else got any questions before I move over and start finding some other stuff? And while we're doing that, all right, we have seen this one. I'm going to need some more desktop space and see what we got here.
You want to take a break?
Yeah, let's take a little bit of a break.
Hang on, we got a video here. We got a Skype coming in.
Okay, good.
Hey, Joyce, can you turn the webcast down, please? Okay. Yeah, I think I hear you now. Can I get a little bit closer shot on your face? it into, plug it right here. Take this mic over here.
Okay. Is this for me or for you?
Gee.
For you before you kill yourself?
Man, I just, yeah. Probably lost it.
I'm assuming my audio. Yeah. kw5gp. I do a lot of my buying directly off of eBay. I don't know how they do it, but the prices are just unreal. The shipping's perfect. I do a lot of SparkFun, Adafruit. The best place I get my lightning sensors from is the Embedded Adventures because they have the I2C version, and it will also do SPI. Everybody else's is SPI, and I'm just an I2C fan. Easier to work with, 2 wires, you're done. So that's why I tend to go there.
Look down a little bit lower. There you go.
And K9MIT. This is Tom's shack. My shack would be a lot messier, a lot more cables, and a lot less usable.
I doubt that.
All right, well, Glenn, we've got a special Skype person just joined us. You turn the Skype up there. This is Joy-T. He lives right outside of Calcutta, India. So your webcast is reaching all the way to India tonight.
Cool.
And Joy-T, go ahead and say hello and tell us your interest in Arduino.
Hey, Glenn, I just got your book from ARRL, and I just wanted to ask you that, I just wanted to tell you that I enjoyed your webcast, and I was flicking through your book. But what I'd like to ask you is that I don't have any knowledge on Arduino programming or Arduino. So what would you recommend for people like us?
Okay. There was actually a book that I brought just for that. I think it's over there. Yeah. There are several that I prefer, but most of the books, and this was actually one of the reasons that I got into writing this book, is most of the books just show you, here's the Arduino, here's a little bit of history, let's go build stuff. They don't really tell you how to use it, and that's kind of where I worked on mine. I tried to give a good intro to the parts and stuff, but as far as the C and the Arduino, I am not a C programmer. I fake it really good. But one of the best books that I have found is this one here. It's called Beginning C for Arduino. It's written by a ham, Jack Purdom. He's K-8-T-E-E, I believe. This is probably the best book that I have found that gives you a good programming side to the Arduino. So that would be my personal recommendation. You can see I've got pages tabbed and dog-eared, so that says I found something in it I like. So that's kind of, that's one of my number one choices. I just picked up a book this week, and I can't remember the name of it. I'll have to post it to Facebook. But yeah, I found another book that I enjoy. But so far, that one is the best that I have seen for learning the Arduino language.
So Joy-T, it's very early in the morning there for you. You got up especially for the webcast, right?
Yeah, that's right. I got up at 6 in the morning, and I really enjoyed your webcast.
Well, we're trying something different right now, and we're trying to make it fun. You're doing pretty good getting in there. Your head is a little small, you know. You need a larger head.
There you go. Stretch it up.
All right.
Well, Tom, I must tell you that I have woken up all night to see your webcast in Dayton. So this is nothing really that tiring, you know. I remember when you did that Dayton, I was up whole night looking at you and the webcast and doing a little bit of work too. You know, it's fun.
Yeah, well, thank you.
Thank you very much, Jyoti. I hope we answered your question.
Yeah, I just if you can type that book's name, because I have your book and what other stuff I need to start with Arduino. That's all I need to know.
Okay.
I will type it in the chat room for you, okay?
All right, you do
Okay,
it.
thank you ever so much. Thank
All
you
right,
ever so
thank
much.
you, and good morning there to Calcutta, India.
Yeah, thank you for getting up early and coming to watch us.
Yeah, bye-bye then. Thank you.
Bye-bye. KU7PDX, the Arduino Mega. Yeah, more memory, more I/O, but it's not
you want to
100% Uno compatible. So a lot of your shields are not going to plug and play. And if you move further and go with the do, you lose the double EEPROM. And yes, you get that 32-bit 86 megahertz, but anything that stores stuff in flash and stuff, you can't do. So you've got to be real careful if you're going to go to the Mega and the Do's, which was one reason why the book focused on the Uno. Consider it an introduction. With the Uno, you're not going to run into a lot of compatibility issues. You've got the Nano and some of the other sizes and variants to play with. And so you're pretty much going, when you buy something, it's pretty much going to work. If you buy a shield that's for the Mega, it may or may not work. For the Uno and stick it on a Mega, it may or may not work, and it might definitely not work on a Do. So, anyway, but yeah, the one thing, and I think kw5gp says it pretty much the best, Google is your friend. I will tell you the best thing to do, learn about code, learn the functions, learn what it can do. You don't need to learn the syntax. You don't need to learn the exact details. Because when you write in your code, you want to building block it anyway. Just a big, big block. And then as you go, if you need to know, I'll tell you right now, I don't know the syntax of half the commands. I can't give them to you off the top of my head. I Google them. I know what I want to do. I know the map command. I know what it does. But if you were to tell me, write you a map statement right now, I'd go Google. And it's just, Google's a good reference. But the big thing is learn the generalities. Learn the big picture of what it can do. And yeah, it definitely is easier to go from Uno to the Mega than the Uno to the Do. I went from the Uno to the chip kit. And okay, WA4HFN. I'm going to need a couple minutes to clear off. Oh, shoot. I'm sorry. I did not bring the Azel controller. And I'm sorry for that because it is sitting at my house driving my satellite array. And I don't have one that I can get my hands on. So the Azel's not going to be here. I do have photos of it if you want to see it. But the Azel did not make it. So, all
right, well, that's something we can do next time. And
yeah.
Glenn and I have talked about this. We probably, maybe every month or 2 months, we might try to do another Arduino show because we're not going to be able to cover everything in this one. Plus, everybody has so many ideas for Glenn to build that this guy can be building new projects every day. So we'll have a lot of new projects next week and or next time, and we will also be able to show you a lot of new projects. I'm just looking here. I see Argentina is in here, Glenn. He enjoys Arduino. We've got Calcutta, India on. We're getting some international people in here tonight. Let's do a prize while Glenn is setting up. We're really pushing him to the limit here. So let's do another prize real quick.
Let's do a book.
We're going to do a book. These books are donated by the ARRL. The author is Glen Popiel, kw5gp, and the title is Arduino for Ham Radio. So Hambot's going to give another prize out here. Please don't type during the prize giveaway. All right, looking for N7ZEV, N7 Zebra. Oh, we got a winner. Okay, we got a winner there. Hey guys, give us about a week or so to get the books out to you. They will be coming, but we'll get them out there to you soon. Glenn built KD4NOQ. He built his special azimuth elevation control. That's cool. I used to work some satellite.
Yeah, matter of fact, the one that David there, KD4NOQ, has is my early first generation version that was actually built with an Arduino. Now I've done it, moved up to a different case May have to go to a different place here, but we can let you see what we've done with that. May have been a good idea that I brought this laptop. I had a last-minute equipment change and switched over to this laptop instead of the other one that I normally do. And the interesting thing about this is the laptop that the book was written on, so it has all the photos and all the cool stuff from the book itself. So I can access anything that's in the book, just happens to be in here as well. And there we go. That is the Yaesu G5400 Azimuth Elevation Controller. That's in what we call, that box is made by a company called Zigo, Z-I-G-O. Their website is zigo.am, Alpha Mike. And you will notice here that all this has is a DIN connector that carries over to an Arduino board, and it's got what? 4 transistors, a capacitor, a jumper block, and an A to D converter. That is all you need to build your own Yaesu GS232A that works with any of the Yaesu models that use the GS232 with that DIN connector on the back. So I think the DXA series has that DIN connector that use the GS232. So for $5, $10, $15, you can build your own GS232A, and that's what we do with the satellite ASL. And let's see what we got here. Okay. Got any other questions?